morning to all of you. My name is Dr. Veena Bharti, Assistant Professor in IT Department at Akgec, Ghaziabad. Today, I am going to discuss about the topic human-computer interface. And the topic we are going to discuss is screen designing. That means how we can create the screen design in creating user interface. So, let's start. So today's course outline is statistical graphics and technological consideration in interface design. So first, what is statistical graphics? That means the graph which we have created. Okay. So here a statistical graphic is a data presented in a graphical format. A well-designed statistical graphic, also referred to as chart, that means that we are using our chart or graph or consist of any picture or any image. Okay, that consists of common ideas communicated with clarity, precision, and efficiency. And it gives the user the greatest number of ideas in a shorter time. Because as we know that if anything is available in a visual form, that it can be easily understood. So that's why graphics is needed. So here it will provide a coherence to large amount of information by trying them together in a meaningful way. Okay, and it will encourage data comparison of its different pieces by the eye, because here graph is available, so we can easily compare between our data. And a well designed statistical graphic display also avoid distortion by telling about the data. Okay, then use of statistical graph. What is the use of statistical graphics? So here this is reserved for material that is rich, complex, or difficult. Okay, so that's why we are using graphics in our data. So statistical graphics should be reserved for large set of data with real variability, and the power of graphics should not be wasted. Third one is the Tuffet 1983 says that table usually outperform graphics on small set of data, 20 or fewer number, or when data sets are non-comparative or highly labeled. So that's why we are using graphics. So components of statistical graphics. So here most statistical graphics have two axes, two scale, and the area to represent the data. A title, that is also called a legend. Okay. So here legend or key. Legend. This one is the legend that shows our title of this graph. Then the pie charts are exception to this general rule. So here the way we are dealing with our statistical graph is to draw an axis, that is the x-axis, and the y-axis. Okay, so this shows our x-axis, that is x scaling. This shows our y-axis, that is y scaling, and this shows the title and the legend. If we are using our color, then we have to use the legend also. And here we are comparing what the data we are comparing, that we have to use here. Okay, so this is the guideline for graphic component, include the following. Then next one is data presentation. If we are going to present the data, then we have to emphasize on the data. Okay. Second is the minimize the non-date elements. Third is minimize redundant data. That means we have to remove our redundant data. Then show data variation, non-design variation, provide the proper context for data interpretation, because if we are interpreting the data, then we have to require proper context. Okay, then the restrict the number of information carrying dimension depicted to the number of data dimension being eliminated. Then employ data in multiple ways wherever possible. That depends our on our data. Then maximize data redundancy, employ simple coding data coding scheme, avoid unnecessary embellishment of grids, okay, vibrations, ornamentation, fill the graphs available area with data. So these are the points we have to consider for data presentation. Then avoid unnecessary embellishment. What is this one? The eye is never absolutely still. It produces continuously slight tremendous with the aid visual acuity. So the result is that when small pattern line boxes or dots are viewed, they shimmer or vibrate. So this is called the vibration that created after blinking, or we say if we are adjusting our eyes, then this graph shown like this. So this vibration can be distracting. Examples are illustrated in this figure. Okay, then axis. Axis. So here axis, basically we know that if we are trying to create any graph, then it has a x-axis and a y-axis. So value of an axis should increase as we move away from the origin. This means that if we have this one graph, then if we are moving away from the x-axis, that means we have to increase our values. Okay, use the horizontal x-axis to show the time or cause of an event, that is the independent variable. And basically if we are trying to create any graph, then we must include in that x-axis as our independent variable and y-axis shows the dependent variable. That means the value of y is always dependent on the value of x. Okay, so when x-axis plot time interval, the labeled point should present the end of each time interval, and the x-axis may also be called abscissa, that you already know that x-axis is considered as abscissa or category axis, and the y-axis the ordinal. Okay, so it is the value axis. If the graphic possesses 3 dimensions, then the third axis, that is called z-axis, and reflecting the graph plane. Because if our graph is 2 dimension, then we are required the x-axis and the y-axis. But if we have to show anything in 3 dimension, that means we are showing the data in a plane. So this is the z-axis. This is required when we have to show any data in a plane. That means the 3D figure. Then scales and scaling. Scales and scaling means what scale we have to use to show our axis. So here, place tick to mark scale on the outside edge of each axis. Employ a linear scale. Mark scale at a standard or customary interval. Start a numeric value scale at 0. We are always trying to start our data with a 0 value, but it depends. If we are required, then we may start it from 100 or 1000, or depends upon the value we are using or we want to show in our data. Keep the number of digits in a scale to a minimum. Display only single scale on each axis. For large matrices, consider displaying duplicate axis, and provide aids for scale interpretation. Provide scaling consistency across 2 or more related graphics. Clearly label each axis in a left to right reading orientation. Then proportion. In what proportion we have to display our data. So here this proportion provide accurate proportion of display surface to the data that represent. Okay, so proportion is also one of the major important point. It provide proportion by conforming to the shape of the data, and second one is the make the width greater than the height so that it can be easily visible. If we are viewing this screen, then in this screen also, as we know that this represent the height of the screen and this represent the width of a screen. So for showing any screen clear, we have to make the width greater than the height. So this is the ratio of our width to height. Then lines. Data lines should be heaviest. That means thick lines must be used. Axis line should be of medium weight, and extend lines entirely around the graphic. Grid line should be very thin or absent. This means if we are showing a graph, that means grid means this is the grid, so this must be very thin, or we are trying to create it as invisible. Okay, then if you are talking about the axis line, so this is our axis line. Axis line should be of medium weight, and the data, if this is our data, if the data is showing by this, then it must be heaviest. That means we have to make it thickest line so that the user can easily see that data. Okay, then next is the labeling. Labeling means to label the data in a graph. So here employ clear, detailed or thorough labeling. Okay, so this is also one of the important point, because according to label we can understood about the graph easily. Okay, maintain a left to right reading orientation. Left to right means this one. So this is the orientation that we are using. If we are using the top down approach or top down, then it must not be easily viewed. Okay, integrate the labeling with the drawing. Do not curve letter to match the shape of curved line. Use only interface, font and weight. For emphasis, use different type sizes. Do not separate labeling from the data through ruled line. Okay, provide information about source of data. Use a legend for complicated graph. Legend means if we are showing any graph, that means if we are showing this as legend, so this is first legend and we have to use second legend in green color so that it can be easily viewed. Then title. We have to show our title clearly so that the user can easily understood about what topic we are discussing or we are comparing. So title should be short, should be simple, should be clear and distinctive title describing the purpose of our graph. Okay, then position the title above, centered or left aligned to the rectangle formed by the extended axis. That means title may be above, may be centered or may be left aligned. Spell it out fully using a mixed case or uppercase font, but it must be clear so that user can easily understood it. Then aiding interpretation of number. So here display a grid on request. If it is not required, then we are not showing a grid. Okay. Permit the viewer to click on data point to display actual values. Grid is basically used in graphics to show the exact value. That means the value of x-axis and y-axis at that accurate or that particular point. For that we are required the grid. Okay. So show numeric value automatically for each point or bar. Permit the viewer to zoom in or an area of the graphics. This is also important because if we zoom in, then we can show it clearly. Permit the user to change the scale value. It is also required that user is also permitted to change the scaling. That means if the graph is shown, this is 1, this is 0, this is 10, this is 20, this is 30, this is 40. But if according to user, if he want to change the scaling from 0 to 5, 5 to 10, 10 to 15, 15 to 20. So user is allowed to change the scaling in our graph easily, because it depends on our data how which type of scaling we are required. If it is a large extent or it is up to a small extent. Permit toggling between a graphic and a table. That means if we want to switch from a graph to a table, then it must also be permitted, or from a table to a graph, because in some situation we are comfortable with a graph and in other situation we are comfortable with a table. So toggling between a graph and a table is also important point to be considered while creating the graph. Okay, Next is types of statistical graph. So statistical graphics take many form. First is curve and line graph. Second is surface chart. Third is scatter plot. Fourth one is bar graph, histogram, segmented, stacked bar, pie chart, and other. Then curve and line graph. So what is curve and line graph? If we are showing our data in a curve form or use the line graph to show our data. So for this, curve and line graph are used. Okay. So display data or curve or line that must be compared in a single graph. Then display no more than 4 or 5 curve in a single graph, because if we are using many curve, then it must be very haphazard manner or the user is confused which line shows which type of data. So avoid too many curves in a single graph. Okay, use only 4 to 5 graph, not more than this, because it makes the graph more confusing and it is not easily understood by the user. Identify each curve or line with an adjacent level whenever possible. If a legend must be included, order the legend to match the spatial ordering of the lines. That means if this is our graph and these are the legends, if this green, then second one is red, and third is your this color. So this color, this type, in this way, if we are showing our graph, so here we have to, if we are showing here legend, so in legend, if this is the first line, then first line, this is first legend, then green shows the second legend, and what is the purpose we have to write here, then this is the third legend, then fourth legend, and this is the fifth legend. So we have to consider the level of legend. That means the legend match the spatial ordering of the lines. Okay. So in this way, if we want to create a legend of any graph, then we must consider or we must follow the order of our graph. Okay. For tightly packed curved or line, provide data differentiation with a line coding scheme such as different color or different line composition type that we have already showed. And legend, in this way we are using our legend in a graph. Highlight curves or line representing important or critical data. If we are showing any critical data, then we have to highlight it also. Then when comparing actual to projected data, use solid curves. Okay, solid curves means thick line we have to use for that purpose, or line for actual data, and use broken curves or line for projected data. So that is the basic difference we are using in our curve graph. So here, if we are using a continuous line, if we are using a broad line, okay, if we are using a dashed line, so that depends on our data, what data we want to show. Okay, so here we have to use the line according to our data. Highlight curve or line representing important or critical data. When comparing actually or projected data, use solid curve or line for actual data and use broken curve for line for projected data. Display a reference index if the displayed data must be compared to standard or critical value. It may also be possible that we have to show a reference with some standard format. So for this, we have to show our standard value as well as the reference we have used. Okay. Display differences between two data set as a curve or line itself. Then second one is surface chart. So here is the surface chart. Surface chart means the area. This is the first area. This is the second area. This is the third area. This is the fourth area, in which we are showing our graph according to the area. So for that purpose, we are using our surface chart. order the data categories so that the least variable is at the bottom. So this is the least variable and it is at the bottom, and the most variable at the top. The largest is at the bottom. Here we have shown this is the largest area, which we have shown in a bottom, because this is the larger area. Okay, and the smallest one is at the top. And also we have to use the different texture or shading coding scheme to differentiate the area below each curve or line, incorporate label with the bands of data. Okay, so here we are using texture or shading coding scheme. So what is the difference? If we are using here shades or different code, so that we can easily differentiate between the different areas. So for this purpose, we are using our texture or shading coding scheme. So this is all about surface chart. Next is our scatter plots. Scatter plot. Scatter plot means it is a two-dimensional display of data. It maintains consistent scale size interval. It provides distinguishable equal sized plot points. Okay, so this is basically used to plot our points. So for that point we are using scatter plot. This is the purpose of our scatter plot. If we have a different point and we have to plot a graph according to which we are using a scatter plot. So if there is more than one set of data on plot, use different symbols. If there are different types of plot, that means if this is of different color, then for showing other data set, we have to use the different color. Visually distinguish points of particular significance through a highlighting technique. And we are also required to use a highlighting technique so that we can easily visualize the distinguish between different points. For that, if we are using, we have shown this is of one data, this is of another data, so we can easily visualize or we can easily differentiate between the different types of data. This is our scatter plot. Then third one is our bar graph. Bar graph means if we are showing our graph in a bar form. So this is our bar graph. Okay. So orient bars consistently either horizontally or vertically depending upon our data. We can show it in a horizontal way, or in a vertical way, or in a horizontal way. Okay, we can show in both way our data. Use vertical bar when item being counted is of great interest. Okay, so a vertical bars are used when the item being counted is of great interest, and horizontal bars are used when data labels are long. Okay, so if this is showing the data, its labeling is long, so for that purpose we are using the horizontal bar, and if we want to emphasize on the item, then we can use the vertical bars. Then to highlight information rather than count, use a meaningful organizing principle. If none exists, arrange the bar so that the length of bar is in ascending or descending order. It is also one of the point which we have to taken into account. That means if we can order it according to some way, that means if we want to create any data according to year, then this is the format we have to follow the year. But if there is no order follow, then we have to follow the length of our bar according to which we have to arrange the data. Okay. If none exists, arrange the bar so that length of bar is in ascending or descending order. Okay. Make the spacing between bars equal to 1/2 width of bar or less. This is also one of the important point. Then if grouping of bars are presented, leave space between the grouping only. If there is a grouping available, then we have to show the space between groupings, not between the data. Then bar graph, if different kinds of bar must be easily distinguished, provide differentiation through a coding technique. Coding technique means if this is the bar, this is one, then this is one of the code. Second code is this one. Third code is maybe dot. Fourth code is maybe circles. So in this way, we have to use the different coding schemes so that we can easily differentiate between the different bars. Okay. If possible, use a pattern or color that reinforces the data. That means we are differentiate using the different pattern and also the different color. That means if this is red color, then second is green color. Third is our blue color, and according to that we can easily differentiate according to our pattern or according to our color. Then provide a consistent ordering for relating group of bar. Display a reference index if displayed data must be compared with standard or critical value. That is same as our previous point. Identify each bar with an adjacent label. Place label below or to the left or to the baseline. When a great many pieces of data must be compared, consider using histogram or step chart. That is also similar as our bar graph. This is the diagram for bar graph. Then next is the segmented or stacked bar. Segmented or stacked bar means order the data category in same sequence. Order the data category so that the least variable is at the bottom and the most variable is at the top. This is the segmented or stacked bar graph. Here this is one of the bar and it has a segmentation provided. Okay, so here the least one is at the bottom and the highest one is at the top. This is the way we are showing our segmented or stacked bar. Okay, limit the number of segments to those that are large enough to be seen or labeled. If we are using many segments, then it may also be creating confusion for the user. Okay, use different texture that we have already discussed. Texture or coding scheme to differentiate the areas within each bar. Okay, then clearly associate label with the bars or segment. Place segment label to the right on a vertical chart or above the horizontal chart. So in this case here we are showing a segmented or stacked bar, and we have discussed the main point that we have to follow while we are creating our segmented or stacked bar graph. Then next one is pie chart. Pie chart means basically it is used to show the percentage between different types of data. That means if there is a data that is exists between 100%, so how much is for first data, how much percent is for second data, how much is for third data, according to that one. So pie chart should be given with caution because it is very difficult to show any data using pie chart. If pie charts are used, they must add up to 100%. Okay, use 5 segment or fewer, because if we are showing many segmentations here in this way, so it will also create a confusion. Each segment should take at least 5%, 18 degree or of the circle. Here, what is the meaning of degree? Because we are showing our data use in a circle. So here, if this is the center, then the data we are showing is shown using the degree. Okay, so this is one of the part, and what is the angle of that one? This, if this is the second part, then what is the angle of this one? If this is the third part, what is the angle of this one, and what is the angle of this one? So this decides according to the angle, because we know that in a circle this point create a 360 degree, then according to 360 degree we have to divide our data according to the degrees they are considering. Okay, so place the largest segment starting at 12 and directly label each segment in a normal reading orientation. That means from this way to this way. This is the normal orientation that we have to follow. If reader for is a label in a small segment are necessary, orient them in a as few angle as possible. Okay. Then this is the diagram for pie chart. It include number with segment label to indicate percentage of absolute value. That means we can also here write if this is our 120 degree, then we can write the degree. That means it shows the percentage. This shows only the angle, but we have to write here the percentage also. That means how much percent it would cover in our data. Okay, texture or color coding selected for segment should not emphasize one segment over another unless it is intended. Third one is highlight segment requiring particular emphasis through contrasting display technique or by exploding it. Never tilt a pie. Okay, so these are the point we have to consider while while drawing our pie chart. Then choosing a graph type. So here we have to choose according to our requirement then that which type of graph we are required in our data. Okay, according to our data we have to choose the graph. Okay, so determine what kind of information is most important for the viewer to extract, according to which we have to select the graph. Choose the type of graph best suited for presenting that kind of information, because it depends on our situation, or it depends upon the data, or it depends upon the user or our interest, that in which way we want to show our data or which format we want to follow, that makes the user easily understood. Okay, so proportion with a scale, best is line graph, bar graph, segmented bar and pie chart. Poorest is line graph without a scale, best is segmented graph or pie chart. Comparison, for comparison we are using bar graph or segmented graph. For change we are using line graph or bar graph. And poorest is bar graph without a scale, bar graph or pie chart. Comparison, pie chart, because if we are showing anything for comparison in pie chart, then it is very difficult for user to understood. Then for change, poorest is segmented bar. Then flowchart. Flowchart basically used to show the flow of any data. So here displayed steps should be designed to follow some logical order. Okay, minimize path link. Orient the chart following common flowchart reading conventions such as left to right or top to bottom. Follow common flowchart coding convention to distinguish between the element. Use arrow in a conventional way to indicate directional relationship. That means if you are creating a flowchart, then there must be a direction so that the user can easily understood which path he has to follow. Okay, highlight element requiring particular attention through contrasting display technique. Require only one decision at each step, because in flowchart either we have to follow one path or we have to follow another path, depends upon the condition. Be consistent in all option ordering and wording. Then technological consideration in interface design. So interface design is also affected by physical characteristic of the data of display device itself and the characteristics of interface controlling software. So graphical system, screen design must be compatible with the compatibility of system that include our system power, screen size, screen resolution, display color, other display feature. So these are the consideration we have to follow for creating the screen design. So graphical system screen design must be compatible with the capability of system platform being used, development and implementation tools being used, platform style guide being used, and the system power. System power means a slow processing speed and small memory may exhibit effective use of system, because if it is slow, then we can use less amount of memory. Feedback and animation capability may be limited because system power is limited, reducing the system usability because it can create slow responses that can be error prone, grossly inefficient, and very aggravating. A system must be powerful enough to perform all necessary action promptly, responsively, and meaningfully. Okay. Then graphical system screen size. Screen size is also taken into consideration because it depends upon our display or memory, our monitor, according to which we are showing our data. So the physical size of available monitor screen area has been gradually increasing because it is the pixel size which decide how the resolution is vary. Okay. So current typical monitor size range from 21 to 13 to 21 inches measured diagonally, with 17 inches being most common. Okay, this is the monitor size and it is designed according to the diagonal range. So this diagonal may be 13 inch to 21 inch and the standard side we are using is 17 inches. The 21 inches monitor resulted in a fastest task completion because it is very huge in size, so user must be very compatible with this. User however preferred the 19-inch monitor. No performance difference was found between a small and medium screen, but the large screen elicited 26% faster performance because the user can easily see each detailed data in a single slide. Okay, the effect of user physical comfort and the possibility of needing an expanded working area must also be considered here. Clearly, the screen size multiple monitor usability trade-off must be studied further. Okay, that's all for today. Thank you.